section of Descriptive Statistics. The title is Tabular and Graphical Presentation. We're talking about how to organize and present the data in many different ways. Okay, so besides types of variables, we can talk about levels of measurement. There are different levels of measurement. Okay? And among the categorical variable, we can talk about nominal scale and ordinal scale. There are two different types of levels of measurement. Okay? And the nominal scale talks about different categories without any ranking. So we have a few categories. I guess zip code is a good example, right? We can have many different areas, different categories, and we assign certain artificial numbers for each category. Okay? But there are no orders. Okay? I mean, does that, if you have 133, is it better than 095, or is it worse than 261, right? The area that has 261 as the zip code. Okay? There is no such ranking or preference implied. Okay? So this is the idea of nominal scale. Okay? So a few examples here. If you ask whether you own any personal computer, well, answers will be yes or no, but there is no particular order or preference implied. Types of stocks owned, well, we categorize different stocks into the growth stocks, value stocks, or other types of stocks. Okay? And internet provider. Okay? Well, we can have what, KD, SK. What else is there? Is there anything else? KTSK. I think there was one more. But anyway, okay. So we're talking about just different types or different brands of internet provider, different company, but no particular order is implied. Okay. But sometimes we can see clear ranks. Okay, among these categories. Okay? Then we call them ordinal scale variable, ordinal scale measurements. Okay? Well, we talked about the school grades, freshman, sophomore, junior, senior. Okay? Which one is better? I don't know. But usually we have some ranks. Okay? Product satisfaction, many times they have a survey. How satisfied are you with this product? Okay? You can have satisfied or extremely satisfied, fairly satisfied, neutral, unsatisfied, or extremely unhappy, something like that. Okay? There is one type of survey. It's called the Likert scale or Likert scale survey. Okay? I'm sure you have seen this type of survey many times. Typically, you are asked to indicate your preference or satisfaction in about 5 different levels. Okay? 0, 1, 2, 3, 4, or 1 through 5. Okay? That kind of survey is called the Likert scale survey. Okay? Faculty rank, professor, associate professor, instructor, and so on. Okay? Standard & Poor's bond rating. Well, if you take a finance course, you will learn about this bond ratings, okay, based on the risk level of the investment. Okay? Of course, in this case, AAA is considered the best or safest investment. Okay? And if you go to D typically means default. Okay? Default means this company could not keep their promise of paying back the principals and interest. Okay? So if you miss any payment on your bonds, you will be considered in default. Okay? Any rating C or below ratings are considered junk bonds. Okay? So, and A rating and B ratings are considered investment grade. Okay? C rating or below are considered junk bonds. Okay? Junk bonds simply means these investments are risky. Okay? Right? Student grades A, B, C, D, F. Okay? All these are examples of ordinal scale measurements. Okay? Moving to the quantitative variable. Okay? Among the quantitative variables, we can talk about a few different scales. Well, actually, two different scales. Okay? First, ratio scale versus interval scale. Okay? Ratio scale, this is a little bit confusing, and many times students ask about this. Okay? But you have to understand this in order to make a distinction between the ratio scale and interval scale. Ask yourself whether the ratio makes any sense in that number. So if you have 1, 2, 3, 4, 5, okay? If you have 4 in this number, does that mean this is twice as good or twice as heavy or twice as long as the number 2, right? Or if you have 2 in this number, does that mean this is half as long or half as heavy or whatever, half as good as the level indicated by number 4? Okay? If that makes sense, how many times or half times or quarter times, those kind of ratios, okay? Then it is a ratio scale measurement. Okay? So length, weight, salary, age, all those things, amount of money. Okay? If you have 2001, right, you can buy twice as many. What? With 2001, what can you buy? Not even ramen, maybe. Right? Anyway, if you have 10,001, you can buy twice as many food or twice as many goods, right? And with the 5,001, okay? So the amount of money is measured in ratio scale. Okay? Interval scale, not very common, okay? But you can think about some special cases. Okay? It is still a quantitative variable. It is a numerical variable. Okay? But in this case, in these types of variables, the ratios don't make any sense. Okay? So if you have today's temperature is, let's say, 12 degrees Celsius. Okay? Does that mean it is twice as warm as 6 degrees Celsius? They both are pretty cool, right? Or if you go to negative, right? If you have temperature of negative 10 degrees in Celsius, okay? Does that mean this is twice as cold as 5 degrees in Celsius, right? Not really, right? If you have Fahrenheit, if you go to Fahrenheit, then it's even more clear, right? Because freezing temperature in Fahrenheit is 32 degrees, right? So any temperature below 32 is freezing, water freezes, okay? Above 32 is, well, above freezing, okay? So if you have 32 degrees and 64 degrees, okay? Does that mean this day is twice as warm as the day with 32 degrees, right? That doesn't make sense, right, in terms of temperature, right? So temperature is an interval scale, okay? What matters is maybe the distance or interval between the two numbers, okay? But the ratios don't make sense, okay? SAT score, the college entrance exam score, okay? IQ score, all those things, the ratios doesn't mean much or anything, right? If you have IQ of 100, okay, does that mean the person is twice as smart as IQ 50 person? Okay? You can't really say that, right? All right. So you've seen this chart before. Okay? This is a baseball attendance chart. Okay? And let's do some practice here. Okay? So we have 5 different variables here, including the team name. Okay? Why don't you think about the types of variable and the different scales or levels of measurements for each variable. I'll give you 1 minute. Okay? So want to try the first one, team name. What type of variable is it?
It's
categorical, right? Yeah, categorical variable or qualitative variable, right? All right. Can you think about the different scales? I mean, there are 2 different levels of measurements in categorical variable, right? No, I'm talking about team name. Yeah, what kind of measurements is it? You have only 2 choices, right? Either nominal, right? Why? Why not ordinal?
It doesn't have any ranking.
Are you sure? You mean you don't have any preference among the Royals and Phillies and Cubs and Reds? You don't, right? Okay. Yeah. I guess if we have Dodgers among here, I mean, everybody would say Dodgers is number 1, right? Or now Texas Rangers. Where is Chu Sin-su now? Texas Rangers. Okay. All right. All right. But I guess you can say, yeah, among these 4 teams, we don't have any particular order. Okay. And I guess preference changes or ranks change. So I guess reasonably we can say that the team names are categorical variable and nominal scale. Okay. Well, how about attendance? Anybody? Attendance? What is your name? 최병욱? 최봉호. Okay. Go ahead. What type of variable is this? Quantitative variable. Okay. Very good. And well, if I ask discrete or continuous? Discrete. Why?
Because it cannot have a half.
Right. Okay. Good. Very good. So we are talking about number of people here. Number of people attended the game, right? So you can have half person, right? Even if you have child, child is considered 1 person, 1 entrant, right? In this game, right? And how about the scale of measurements or level of measurement?
Ratio scale.
Ratio scale. Why?
Because the ratio between the measurements is meaning.
Right. Ratios are meaningful, right? If you have 20,000 people attended, that's twice as many as 10,000 people attended, right? So ratios definitely make sense. Okay. Good. Well, how about next one, temperature? Anybody? Okay, go ahead. What type of variable first? Numerical or quantitative variable, right? Right, okay. All right, and then what about the scale, the types of measurements? Interval scale, okay. Not ratio scale, right? We talked about the temperature here as an example, right? So again, if you have 80-degree temperature, that doesn't mean it is twice as hot or twice as warm as 40-degree temperature, right? It's just the measurement or scale of temperature, right? Good, very good. Okay? Well, the next two variables are kind of weird. It says weekend promotion, right? And if you take next class, next semester, Introduction to Econometrics, you'll learn about this type of variables. These are not real variables. These are artificial variables, right? So in statistics, we call it dummy variable. What is a dummy? It's a puppet, right? It's a kind of a doll, right? Or puppet, or it's not real person or real variable. Okay. So we artificially assigned numbers to this variable, right? So the question here was this game played during the weekdays, or weekend, right? And obviously, I guess if you play a game over the weekend, attendance probably is better than the weekday games, right? So I guess usually, you can assign either way. Weekend will be equal to 1 if it's weekend, right? And 0 means that this game was played during the weekdays, okay? All right. Same thing here, promotion. Sometimes they have some promotion, right? In order to attract more crowd, they have baseball cap day, right? So everybody who comes in gets a baseball hat, right? Or sometimes they have fireworks and so on, right? So whether there was any type of promotion or not, right? That's the artificial variable. Yeah. Well, if you have to classify these variables, right, then what type of variable are these? The weekend and promotion. Categorical or qualitative, right? Even though they are recorded in numbers, these numbers don't mean anything, right? So you can say these are categorical variable. We're talking about two different categories, whether it's weekdays or weekend, right? Or there was a promotion or not, okay? So you can definitely answer with yes or no, right? For each category, right? So it is definitely a qualitative or categorical variable, okay? What kind of scale? If you have to ask, right? Nominal, right? Instead of ordinal, right? Because we guess there is no particular rank between 1 and 0. Okay? All right. So why don't we have a few more examples or exercise? And I pulled up our textbook. Since this is only second class of the semester, I suspect some of you do not have the textbook yet, so I pulled up the textbook here. Okay. I don't know what page. This page is slightly different from your printed page, but why don't you look for, if you have your book, or you can just read from here. 2.5, exercise 2.5. 2.5, 2.6, 2.8. I'll give you a few minutes, and why don't you read and think about it. All right. So we talked about the summary table, which is the simplest form of data organization. Okay, once you collect the data, the next step is presenting the data and convey the information on the data to your audience. Okay? And the simplest table was the summary information. Okay? And then you can go a little further in case you have two different variables. Okay? Example here was the size of invoice, small amount, medium amount, large amount, and then there's another criterion whether the invoice contains errors or not. Okay. All right, so you can do that. Okay, and once you do that, These are raw numbers, raw counts of frequency. Then you can convert it into relative frequency, okay? And you can divide each cell number by the total, grand total, okay? And you can see 42% of the total invoices belong this category, the small amount of invoice without any error, okay? Oh, before I forget, I need you to sign this. This is, well, it's in Korean, but basically this is, I'm asking your permission to tape record this lecture. If you look at the monitor back there, you will never see your face there. Also, it will be probably highly unlikely that your face will show up on the tape, okay? But just in case something happens and you show up, okay? The university needs your permission, okay? So why don't you pass it around, fill out your information, okay? Okay. So you can do the percentage of overall total, okay? But there are a couple other things you can do with this table. You can do percentage of row totals, okay? So you can see this row totals here at the bottom here. Total of 330 out of 400 invoices. 335 invoices were without errors. 65 were with error, okay? So compared to the row total, I mean, out of 335 invoices that did not have any errors, right? How many were small, how many were medium, and so on, okay? So you can divide this cell frequency by the row total, okay? And convert it into percentages, 89%, 71%, and so on. That doesn't make sense, does it? Oh, I'm sorry, I was talking about column total, right? Okay, row total. Row totals show up here, right? So the total of the first row was 190. Total of the second row was 140, and so on, okay? So you would divide 170 by 190, 100 by 140, okay? The story here would be, among all the small amount invoices, almost 90% did not have any error, okay? And about 10%, 10.5% of invoices, small amount invoices, contained errors, and so on, okay? So that makes sense, okay? So you can easily check whether you are doing row total or column total. If you are doing row total, you will see 100% at the end of each row, okay? Or the last column will always have 100%, okay? Likewise, you can do column total, okay? So that's what I explained first, okay? Out of 335 invoices that did not contain errors, how many were small, okay? And it turns out that 50% of the invoices, among the total invoices that did not contain error, 50% were small, about 30% were medium, and about 20% were large, and so on, okay? So that's one thing you can try. All right, we can move on to the numerical data or quantitative data, okay? And we can start with the ordered array. Once again, we start with the most primitive and simplest form of data presenting the data, okay, which is ordered array, okay? And ordered array is simply a sequence of data in rank order from the smallest value to the largest value, okay? So basically you sort all the numbers and rearrange it from the smallest to the largest, okay? Why do we do that? What is it good for? Okay? First of all, when you do that, just like here, okay, you can see the range of the data values. Okay? Apparently, the smallest number is 16, and the largest number is 42. Okay? Clearly shows the range of the data. Okay? And then you can also easily identify outliers. Okay? Outlier means unusual observation, which is far away from the rest of the data points. Okay? So if you have something like 62 here, right? That means among the day students, one student is 62 years old. Okay, so you can see that compared to the usual ages, I mean, most of other students, one particular student has very high age. Okay, that's called that's the concept of outlier. Okay. So once you rearrange the numbers in ordered array, you can easily look at the outliers, whether there are any outliers. Okay. More popular form of data presentation in terms of quantitative data, frequency distribution. Okay. And frequency distribution is typically a table. Okay. And it is, here's an example. Okay? So we are going to present the data in different classes, okay? And count the numbers of observations in each class and present. Okay? And then it'll provide a good overall idea of how the data points are distributed, okay, to the readers. Okay? So the steps to do that is, first of all, you have to determine a suitable width of a class. And ideally, each class should have equal width. Okay? And that way, we can easily grasp the idea about the distribution. Okay? So once you decide the width of a class, you can establish boundaries, lower boundary and the upper boundary of each class. Okay? And of course, you should make it to avoid the overlapping. The classes should not overlap. Okay? And well, this is just a rule of thumb. There is no hard and fast, the rule. Okay? But typically, we just consider anywhere between 5 and 15 classes are normal or typical, okay, or usual. Okay? So what that means is you have to determine the width of each class by dividing the total range. Again, the range is the highest value minus lowest value. Okay? And divide the entire range by the number of classes you desire. Okay? Then you will be able to find out, how wide each class should be. Okay? So that's how the width is determined. Okay? So here is an example. Okay? Suppose we have how many? I don't know how many observations, but we have some numbers here. Okay? And apparently this is an ordered array. Okay? We have listed these numbers from the smallest to the largest. Okay? So the range is 58 minus 12. So range is 46. Okay? And let's say we decide to have 5 classes. Okay? Then you're going to divide 46 by 5. Okay? And we come up with about 10. Is that exactly 10? Yeah, slightly less than 10, okay? But you can round up, okay? Because you cannot have half class, okay? So we will end up with 10 classes. I'm sorry, there are 10 for width for each of the 5 classes, okay? So, because those 5 classes have to cover entire range, okay? We may have to start slightly less than the smallest number, and the last class will have to end at the upper bound of the last class must be slightly larger than the largest number. Okay? So if you set it up this way, from 10 to 20 or less than 20, because the classes should not overlap, right? So 10 to less than 20. So if there is any number like 19.999, right, that will belong to the first class. Okay? And from second class starts from 20 to less than 30, and so on. Okay? Then the last class will end at 60, less than 60. Okay? And obviously that covers our largest number, which is 58. Okay? So that will work. This setup will work. Okay? And then usually we do one more step, which is calculating midpoints for each class. Okay? And you will see why. For many purposes, usually charting purpose, drawing the chart or graph, okay, we use midpoints. Okay? So you know how to calculate midpoint, right? How would you calculate midpoint for the first class, for example? Yes, average, right? So 10 plus 20 divided by 2, right? Well, it may be slightly higher or lower than 15 or 15.01 or something like that, but you can round up or round down, okay, and come up with the midpoint. Okay? Well, in this example, it works exactly the way. Okay, and then finally, you can count observations that belong in each class and list the frequency for each class. Okay? And the result is right here. Okay? So we presented this data in nice tabular form. Okay? Constructed a table. Okay? And we have 5 classes, midpoints, and frequencies. Okay? And typically, we also add the total at the bottom. Okay? So we have total of 20 numbers, 20 observations. Okay? All right? That was the raw frequency. Okay? But many times we want to know the relative frequency. Okay? So compared to the total number, how large is this class, or in terms of numbers? Okay? So many times we convert the raw frequency into relative frequency, and you know how to do that. You know, we divide each frequency by the total, okay? And we come up with these fractions like 0.15, 0.3, and so on. Okay? Or many times for your purpose, you can convert the fractions into percentage, okay, and present it in the percentage form. Okay. In case of relative frequency table, of course, the bottom, the total, must be always 1 or 100%. Okay. Make sure you check that. Okay. Another thing you can do is construct your cumulative frequency. Okay. So you can ask the question, you know, how many observations are found in each class. Okay. But sometimes you want to know how many observations are found less than certain number. Okay. So let's say out of all those 20 numbers, how many are less than 40, right? Then, of course, you have to add 3 and 6 and 5, okay? So that will be the total cumulative observation, okay? So you can see here in cumulative frequency column, okay? 9 is, of course, 3 plus 6, okay? 14 is 9 plus 5, okay? So you can add the frequency in each class, okay, to the cumulative frequency in previous class, okay. Then you will find out the cumulative frequency, okay. And of course, the cumulative frequency of the last cell or last class would be exactly equal to the total. Okay? Or you can convert those cumulative frequencies into cumulative percentages, right? And sometimes it's easier to look at it, okay, to understand the distribution. Here, they say 70% of the observations are below 40, okay? And almost half, 45%, the observations are below 30, okay? Something like that, right? And again, the cumulative frequency or cumulative percentage of the last class will be equal to 100%, okay, in that case. Okay. Any question? Pretty easy, huh? Just wait. We'll get into a little more complicated thing. Right? All right, so now we talked about presenting the data in tabular format. Okay? Now, how about the more visually pleasing forms of data presentation, right? Which is graphical display. Okay? All right, so starting from the simplest one, we can talk about bar chart. Okay? And all right, I think we had this data before in the last class, banking preference, okay? And out of, let me see if I can quickly locate the, is this it? Yeah, okay. This is the table, the summary table, okay? And survey of 1,000 banking customers. Okay, so you asked 1,000 people, which is your most preferred way of banking, right? And we found out these percentages. Okay, so for this simple data, I guess it's pretty easy to understand what's going on in the data. Okay? But for many purposes, many cases, we convert this table into a chart. Okay? And that is this case, okay, bar chart, okay? And instead of just looking at numbers, if you look at the length of each bar, right, then sometimes it's easier to grasp the difference, right? Well, from the number we knew that most customers prefers in-person at branch, okay? So I guess most people want to actually go to the bank and take care of the business with people or tellers. Okay? But if you look at the length of the bar, then you can say that is very significant, right? It's almost twice as long as the other preferences. Okay? And very few people want to do banking business on the phone. Okay? So bar charts nice in showing the data, the information contained in the data pretty quickly, okay? And clearly. Okay? Another way to present the same data is probably pie chart. Okay? Pie chart, we're using the same information, the banking preference information, right? And if you compare the bar chart and pie chart, what would you say? Which one do you prefer? Does pie chart have any advantage over bar chart? For what purpose would you use pie chart instead of bar chart?
It clearly shows dominance of the total, of any part in the total.
Okay, dominance. Okay, or I guess proportion. I guess. Right. So yes, from the bar chart, we could see that we can see the rank easily, right? This is the longest, second longest, and so on, right? But the advantage a pie chart or a bar chart is you can look at the total percentage, right, in proportion, right? So you can see this light blue area, which is, I think something's messed up here. Light blue should be, I think, in-person, sorry, that's right. The in-person at branch, yeah, that's pretty large compared to the other areas, okay? And compared to the total, right, you can see the relative size of each category, okay? So, you know, many people prefer a pie chart over a bar chart for cases like this. Remember, we are talking about categorical information here, right? We're talking about different categories, okay? So when you're dealing with the categorical data or qualitative data, okay, many times pie charts are selected, which is the presentation of choice. Okay? How would you construct this pie chart? So you can have these numbers, you know, from the summary table. You find the 16%, 2%, 7%, and so on, right? But then you have to decide basically the degree of angle, right? You know, how many degrees, right, you would allow to have for each piece, each, I guess, slice of a pie, right? Let's look at this as a pizza pie, right? And for each slice, right, you have to calculate the degree of angle accurately, right? Any idea how to do it? How would you convert 16% into, you know, how many degrees? I think you have, you know that, right? Have you done that in I don't know, elementary school or middle school? Yeah. Have you constructed the pie chart without using computer? How would you do that? First of all, how would you calculate the degree? How many degrees you have to allow for each category? In Korean? You can speak in Korean. You know? Any idea? Come on. Okay, what equation? How? Give me.
You can choose x for
Okay.
degrees.
Uh-huh.
In Korea,
Yes.
100분의 16 곱하기 360.
Excellent. Right. Why is 360? Because the entire circle is 360, right? And obviously that category has 16% of the total, right? So that's how you would calculate, right, for each category, right? So x2 would be 2% times 360, right? And then when I was in elementary school, we used what is called the protractor, bundogi, right? Have you ever seen this thing? With the angle, degrees, and so you could draw a circle using a compass, right? And draw a line, and then using the protractor, you measure whatever, you know, degree, right? And draw the line, okay? Have you ever done that? Did anybody do that? Right? Okay. Well, these days nobody does that, I'm sure, right? You can easily do it on the computer. So let's see, let me show you how to do it. I'm sure you can figure it out, but let's say well, is my here we go. Bar pi. Just 1 second. It's 100%. Okay. Somehow not showing the. Okay. All right, so we have a data here, okay? And this is a slightly different data. It has ATM transactions. If you read the textbook, you found out that the textbook provides lots of data, okay? And I tried to upload the data for you to try on your computer. Unfortunately, on our portal, they don't allow multiple files to be uploaded at the same time, okay? So I think last time I uploaded the files on something like Box and let my students download, okay? So I'll do that probably in a couple of days, okay? So you should be able to see all this data, download the data, and try the exercise problems, okay? All right, so let's say bar chart first. What you can do is, I think you can do this, just highlight 2 columns, the name of the category and the frequency, and go to Insert. Well, you can choose either vertical or horizontal, but let's try this one. All right, then it just creates the bar chart so easily. So it's a piece of cake, right? In case you want to do pie chart, of course. All right, you can use the same data to go insert, and you can choose any of the types you want, okay? And all right, here we go. Apparently it's not showing all the categories right here, okay? And you can do a few more things to make it more, I guess, pleasing visually, okay? It doesn't show percentages here, right? So you can somehow it doesn't look like real circle. It's a little longer. Okay, and I think you do right click here, data or series format, and maybe not. Label, okay, yeah. So when you did the add labels, it shows actual frequencies, okay, and yeah, or you can do, in case you want relative frequency or percentage, then you can do so. I think what you can do is highlight this column and then select the percentage column. You have to press Control key, and then you can select 2 separate columns or areas, okay? And go to insert. Let's try this one for this time. Okay. All right. Yeah. Sometimes they want some this kind of artistic presentation. Okay. And you want to right click and all right. It shows percentages. Okay. So why don't you try? There are many things you can do. Depending on how you want it, you can instead of just identifying with colors, you can make these each category name to be linked to each slice. Okay, if you like. Okay. So again, it's if you master these skills, right? You'll do well in your future job. Okay. Any question? Just try that at home. Okay. All right. So let's move on to a little more complicated case. Slightly more complicated presentation of the data is called the Pareto chart. Okay. How many of you have taken economics course yet? No, this is your first semester, right? Okay. Good. All right. Well, Vilfredo Pareto Vilfredo Pareto, okay, was an Italian economist, but he was a jack of all trades. He was, he had talents in many different areas. He was an economist, he was an engineer, he was a sociologist. Okay? So he made many contributions in in many different fields of study. Okay? In economics, you'll probably hear Pareto equilibrium, the concept of equilibrium. Okay? But in mathematics and statistics, he came up with what's called law of critical few. Law of the critical few. Okay? And many times this is just simply called the 80-20 rule. Okay? This is a very funny, or not funny, but interesting rule. Okay? Or not exactly a rule, but a phenomenon. Okay? And you find this phenomenon in many different areas of our life. Okay? For example, in terms of economic area, you find out 80% of the total wealth is owned by 20% of the population. Okay? If you look at the total world GDP of all the countries in the world currently, okay, you find out about, I think, 82%, okay, about 82% of the total wealth, total income is made by about 20% of the population, or it's called the quintile. Okay, you'll learn about this probably in the next chapter. Okay, you divide the entire group into 5 categories. Okay, top 20% is called the first quintile. Okay, and second quintile, and so on. Okay, actually, the what gave Pareto this idea was the land ownership at that time, around 19th century. In Italy, okay, the 80% of the land was owned by 20% of, I guess, richest 20% of people. Okay? So he got the idea. Okay? But then people found out that this 80-20 rule applies to many different areas. If you run the business, for example, and if you look at any company, okay, 80% of the total revenue, sales revenue, comes from 20% of their total product. In other words, some of their popular products, okay, bring in most of the money, okay, a company makes, okay. So, and in engineering and the quality control areas, they also find many cases where you can apply this rule. Okay? So the Pareto chart, what we call Pareto chart, is we of course are dealing with the categorical data, okay, in nominal scale. Okay? And Pareto chart is a combination. Let me show you this first. Okay? It's a combination of bar chart and line chart together. Okay? So first of all, what we do is we create a bar chart, a vertical bar chart, where categories are shown in descending order. You have to sort it first, okay? From the largest frequency to the smallest frequency. Again, the whole idea of Pareto chart is to identify critical few or vital few from trivial many. Okay? Which categories are most important? Which categories are making the most contribution to whatever the information we are trying to, convey? Okay? So you create the bar charts in descending order, and then on top of that bar chart, we put a cumulative polygon. Okay? And this is what we call cumulative polygon. Polygon is 다각형, right? Right? So we have this. You can say line chart, or you can say polygon. Okay. So from the same data, banking preference data, we can create this kind of Pareto chart. Okay. And first of all, you have to sort the categories from the most frequent to the least frequent. Okay? Put those bar charts together. Okay? And then from the top of the first bar chart, okay, you create the cumulative. These are cumulative frequencies, right? So first category has about 20%. I'm sorry, 40%. So you start from the 40%. And the second category has, I guess, slightly more than 20%, right? So if you add the 40% and let's say 21%, right? Then it's going to be about 61% or 62%, right? And then on top of that, you add the next category, which is, I would say, about, I don't know, 17, 18%, right? So that's going to be the total cumulative and so on, right? So we have one axis for bar chart here, and the other axis for cumulative frequency here. Okay? That's what we call Pareto chart. Okay? And this Pareto chart is used in many areas frequently. Okay? And creating this in Excel is slightly complicated. Okay? So why don't we try this today? Okay? I'll show you. In your textbook, in the back of each chapter, there is Excel guide. Okay? So I have 6th edition here. I'll go get 7th edition pretty quickly. Okay? But on 6th edition, if you open page 96, so towards the end of chapter 2, what page is it in 7th edition? Excel guide at the end of chapter 2.
Oh, is this the one? Or did I find
Chapter 2 Excel guide, so page 122. If you open page 122 in the 7th edition, page 96 on 6th edition, right? There are Excel guide, and I recommend you in the beginning of the semester I'm sure you have had some parties already, right? So now it's time to settle down and start working, right? And next week I'm going to hand out first homework problems, okay? So maybe this weekend is a good time to sit down and go through this Excel guide, okay? You don't have to do everything. This textbook gives you 3 different types of Excel guide, okay? Usually they start with PH Stat 2, okay? This is not a part of Excel. This is actually, what do they call? The additional function, some additional software, okay? You have to download it, okay? And you may or may not be able to download it free, okay? But don't worry about it. I don't use this because this is not a part of plain vanilla Excel, okay? And the reason why I don't use it is once you graduate the college and get a job, okay, may or may not be able to use it because I'm pretty sure every company uses Excel, okay? But I'm not sure whether every company has this additional function installed on their computer, okay? So you should be able to use just Excel, plain vanilla Excel, okay? And do whatever you want, okay? All right? So I don't use it, but if you want to use it, that's fine with me, okay? But my recommendation is move on to the next section, PhD 2 stat. Oh, right. So in my version 6, the next column shows in-depth Excel 2007. Maybe the 7th edition say 2010. Does it say 2007 or 2010? In-depth Excel. Oh, it just says Excel. Okay, because I don't think there's too much difference between 2007 and 2010. Okay? So why don't you follow through these sections, these paragraphs, okay? And see if you can do whatever they want to do, okay, in Excel, okay? So make yourself familiarized with Excel. That will help you in, first of all, doing a homework, okay, and following through this course, okay? So, excuse me. If you go to, where is Pareto chart? Okay. In 6th edition, it's page 102. So about 6 pages later, maybe in 7th edition, about 133, 34, there should be Pareto chart. Did anybody find?
126.
127? Okay, yeah, page 127, right? In 7th edition. So there's a Pareto chart instruction, okay? And you can follow through that, okay? But let me show you how to do it today. The nice thing about this video recording is in case you want to see it again, you should be able to do that on the web, okay? So, first look at the ATM table. Be patient with me. I am going to do a little bit slowly. All right, so let's go back to this data. Oh, come on. Okay. Okay, I have this data now. So from this data, you have to do sorting first. It's already sorted, okay? But how you do is just highlight these 3 columns. Don't include the last column, which is total, okay? I mean last row, okay? And go to data, sorting, and select, you have to select the criterion, okay? And you have, let's select based on the frequency, okay? And descending order, okay? And yeah, it's already sorted, okay? So we are ready to use this data now, okay? And then the next step is you have to add this column. See, original data doesn't have this cumulative percentage, okay? So let me just retype this. Cumulative percentage, okay? And the way you create is here, you have to enter equals C4 because the cumulative percentage for the first row is exactly this one, C4, right? But for here, you have to add this function D4, which is this one, plus this one, right? So you have the formula for this cell. And then you can copy it down, just drag it down all the way, actually, all the way down to here, okay? Anyway, okay. So now we have cumulative percentage, okay? The next step is select columns A, C, D, okay? So you have to select this one, and then if you want to select the A, B, C, D, you can just do this way, right? But in case you want to do separate, you have to do this one first. Click, hold it down, the control key, and then do like that, okay? So you have selected the 3 areas, okay? And then we are ready to create the bar chart first, okay? So go to Insert, Vertical Bar Chart. You can choose the first one. Okay. Well, we got a problem here, because we have cumulative percentage also in the as a bar chart. But you remember, we want cumulative percentage as a polygon, right, instead of bar chart. Okay. So here, go to under the chart tool. Where is chart tool? Yeah, I think here. This is the chart tool. Okay. You know, that's one problem we have to overcome. Your instruction in the textbook is in English version, okay, English Excel version, and I'm sure some of you, I mean, many of you have a Korean Excel version, okay. But well, since I have a Korean version here, I think it may help you. Okay. Okay, so here chart tool and select format, okay, and here select cumulative percentage, okay, and then okay, and then go to the next step is click format selection right here. So 선택 영역 서식, okay, format selection, selected area, okay, and then change this from main axis to supplemental axis, secondary axis, okay, and close it, okay. And what happened just now is we used to have only the numbers on this side, okay, but now we have the secondary axis here, okay. Well, and then you see this, the red bars are already selected. These are cumulative percentages, okay. So what you can do is go to design here and select chart type, and then you select this line chart with the markers. Okay, these dots in the, on the line are called markers. Okay, so select that type, line chart with markers. Okay, and close it. There we go. Okay, so we have something that resembles the Pareto chart now. Okay, but we got still some problems. Okay, the problem is if you look at the example in the textbook and my slide, okay, this polygon is supposed to start from here, right, on top of the first bar. Okay, and the reason why we have this problem here is this scale is not consistent with this scale. Okay, so now we have to do that job. Okay, so what you can do is just right click here in this axis area, right click, and the axis format, and right now everything is set to automatic. Okay, but that's why it is right now you see the 60% as the maximum. Okay, so we have to artificially change it to 100%. Yeah? So click here, fixed, and make it 1. Okay, and that should take care of it. All right, so we have first axis or main axis from 0 to 100, right? And now we have to change this axis, do the same thing, right? Go to the right click here and format axis, okay? And again here, fix and change it to 1. Okay, there we go, right? So we have nice looking Pareto chart here, okay? If you want, you can include the title, okay? I want you to try this and find out, right? You can include the title in the graph, or you can bring these legends. Right now, I think this is the default location of the legends. If you want, you can bring it to the top or bottom or whatever you want to do. Okay? So try that at home. Okay? Any question? Yeah.
On the right side of the chart, why do you need the supplementary scale?
This one is the secondary scale, right?
Why do we need it?
Because we have two different series of the data. Okay. I guess your question is, you're gonna have 100% anyway, right?
Yeah.
And that's a good question. My hunch is in some cases you may not have 100% on both sides. Okay, that's why. Okay, but let me think about it. Okay, or maybe you can think about it. Okay, whether there will be any case where for bar chart you can have only slightly different scale. Okay. Yeah. And if you do the web search, okay, there are many programs you can locate on the web, okay, other than Excel, through which you can create the Pareto chart, okay. And in many cases they don't start from the top, okay. So depending on, I guess what that means is, in some cases for the bar chart you use regular frequency instead of relative frequency, okay. But for the polygon, you use cumulative frequency, okay, right, or relative frequency. So you can modify these Pareto charts depending on your purpose. Okay. Sometimes you may think that presenting actual number instead of percentage for the bar chart make more sense or clear, or convey the information more clearly. Okay. In that case, you can choose to do so, right? in that case, this polygon is not gonna start at the top of the first bar, right? Okay. If you use actual frequency, it's because the two axes will have completely different scale. Okay. So it's up to you. Okay. But following the way they present in our textbook, okay, we should do it this way. Okay. So if you have any homework problems creating Pareto chart, okay, try to follow it this way. Okay. It'll be easier for me to grade. Okay. And well, again, I'll try to find out how you can review this video tape on the web again. Then you should be able to repeat this, show this. I can show this to you later if you want me to. Okay, let's try to go on. I have about 10 more minutes here. Another simple presentation is side-by-side bar chart. Okay, and I think yeah, you can try at home many different ways. Okay, but the benefit of side-by-side bar chart is sometimes you want to compare these numbers within each category, right? So here we have a contingency table with the two variable case, okay? And sometimes you want to say, the whole idea of the contingency table was among the invoices with no errors, how was the distribution of sizes, okay? Among the invoices with the errors, okay, how were the numbers distributed, right? So for that purpose, we can do this way. First of all, we create 3 bar charts for one category, I guess in this case, second column, okay? And then you can create the same bar chart for another category, okay? Then you can clearly compare, right? Apparently the distributions are different between error category and no errors category. Okay, so that's the idea of side-by-side chart. Okay, I'll let you try that at home. Okay, maybe you can use the same data and you can use any of these chart choices. Okay, and see if that works. Okay. And this is a slightly different format. This is called the stacked bar chart. Okay? And our textbook does not explain, okay, the stacked bar chart. Okay? But if you can try at home. Okay? So instead of, for example, using the same data, instead of creating side-by-side bar chart, you can create stack. Then you will see one bar here, but divided into percentage, right? So the yellow will be the largest percentage, and then the green, and then pretty small white. Okay, so you can see the relative size of each category within errors, the invoices with errors. Okay. So you can try those things. All right. What about numerical data or quantitative data? Okay. And we can do a few interesting things. Numerical data. Okay. The first one is stem and leaf. This, starts from the ordered array. So in order to do the stem and leaf display, okay, you create the ordered array first, just like this. Okay, and then you notice that some of the numbers are in teens. from 16 to 19 through 19, right? The rest of numbers are 20s, and there are a couple of 30s and just one 40s, okay? So another way of showing the distribution is just like, well, we didn't talk about histogram yet, okay? But we created bar chart like midpoint 15, 20, 25, something like that, right? We have seen this bar chart previously, right? So instead of doing that, we can easily, in order to create a bar chart, we have to, first of all, create the classes and then find the midpoints, right? But without doing all that, we can quickly do this, right? How many numbers are in teens and 20s and 30s and 40s, okay? So use the 10th digit as the stem, right? And then for the leaves, first of all, stem and leaves, we're talking about tree here, right? We have, I guess, stem and leaves, okay? So we use the 10th digit as the stem numbers here. And then for leaf, we use the first digit, the single digit numbers, 6, 7, 7, 8, 8, 8, 9, 9, right? 6, 7, 7, 8, 8, 8, 9, 9, right? So you just list those single digit numbers as the leaf, right? Well, it has nice characteristic because you can quickly see the distribution of numbers, right? Apparently we have 8 numbers in the teens, 7 numbers in 20s, 2 numbers in the 30s, and 1 number in the 40s, okay? So it shows the size of distribution instead of this, we are doing the sideway distribution, okay? For the 9 students, you can do the same thing, okay? That's the idea of stem and leaf, okay? Yeah?
Can this only be used with 2-digit numbers?
No. Depending on your purpose, right? Suppose you have distribution of numbers like 123, 142, 128, 129, 131, 137, and so on, right? And you can decide to use first 2 digits, 100th digit and 10th digit, okay, as the stem, right? So 12, 13, 14, and then you can write 3, 8, 9, 1, 7, right? It's up to you, right? But somehow you have to make it clear that this is the 10th digit, okay? So stem, on top of the chart you can say stem unit is 10, right? Then everybody will know this is 120, 130, 140, okay? Excel guide shows you how to do that in Excel, right? But I want you to do this by hand, okay? You don't really need Excel to do this, right? So you should be able to create the stem and leaf chart by hand, okay? You may need to do that for the exam, okay? So make yourself familiarized with that. All right, I think we are out of time today, so we're going to continue with this on Tuesday. Any question?